Now just get this slope, and just understand the slope concept first, then you move ahead to your 11th slide, the last slide of today. So over here you can see that this is a point P and this is your point Q, and I just said that a point is moving from this position to this position. Okay, this point P is moving towards the Q. Okay, so how much what is said to be the inclination, how you're going to calculate the inclination or slope of this line. Okay, so you can understand in a way that let us write down the coordinates of this point, and you can understand it in a way that this point is having your x coordinate over here and your y coordinate over here. Okay, this is it, and it is your, for example, this is your y1 and this is your x1. Okay, and you call it this is the point P, and in the same way this Q point is having x coordinate over here at this position, and the y coordinate is located over here. Okay, so this is your, for example, this is your y2 and this is your x2. Okay, so the point is your x2 and your y2, because this point is lying on a plane, so every point is expressed as the ordered pair of two tuples, you know that. So we have to find out the slope value. What is the slope value? So actually what exactly happening is that the point moves from here to here, it runs from here to here, and then it rises from here to here. That's how it achieved at Q point. Okay, so your slope m is the ratio of your rise over run. Okay, so what is the length of this yellow line, and what is the length of this horizontal yellow line? So you see the horizontal yellow line is actually your whole x2 minus x1 length. You are getting this length, x2 minus x1. So this thing tells me that my run length is x2 minus x1. And what is the value of your vertical yellow line? You see this whole length from here to here is equals to your y2, and if you subtract y1 from this y2, you are going to get the remaining portion. This portion is y2 minus y1. Okay, so that's how you calculate the slope. So this is your slope, that's why. Okay, so slope actually so explained with the help of maintaining a right triangle related to 2 points, and these 2 points are forming the hypotenuse of this right triangle. All right, so actually if you are having a straight line, you just obtain any 2 points lying on that straight line and get the slope. That's how you obtain your b1. Slope is your b1 here. Okay, and this line, green line, is intersecting y-axis at this point, and this is your C, which we have represent as B0. Okay, so that's how we obtain the values. And once when we dealing our population data, it was your beta naught and this was your beta 1. So, and we are not doing that, we are just actually concentrating on the sample data. We obtain our B1 and we obtain our B2, B0 by obtaining the best fit line with the help of our ordinary least square method. Once we obtain the best fit line, we take out the slope of the sample, we take out the y-intercept of the sample best fit, and then with the help of that we are going to calculate the beta 0 and beta 1 of our population with the help of T distribution method, a long method, a second topic. Okay, so you see here there is a briefing given to you graphically. This, it's too easy. I mean, you see here they have taken a y in the x-axis. This brown line is representing the line of the best fit of your sample data. Okay, you can see that this brown line is cutting your x-axis at this point. So this is your B0, and it is a length from 0 to B0, so this is a B0. And the slope of this brown line is calculated over here, and this is the slope value, and it's representing by the B1. All right, these are the scattered plots. These are the observed or actual values, which are so done over here with the dots. You can see all these dots are the observed values, and you can say, and you know that the observed value is so obtained with the help of by adding the error with the estimated value, and we have discussed that already. This is the sample observed value, this is the population observed value. So that's it. Now you see this is the observed value and its position, its location, which is actually over here. This value is so obtained with the help of this method. Okay, you just calculate the corresponding y cap with the help of this equation. You know your b naught, you know your b1, okay, and you know your corresponding x value, which is lying over here. Okay, you just substitute over here the error value you have just calculated over here. You just substitute and you just get your I dash. Actually, the reason is that if I just say that I want to find out the corresponding y value which is not present in the sample data, and the equation is given to me, so I can just I will just substitute the independent variable value which is not present in the sample data, and I'm going to get the corresponding y answer of that related to that independent variable. Okay, so that's why that's how the equation is helping me. The sample data values are right in front of me. It is not causing me any problem. And if I want to find out the actual value corresponding to some independent variable answer which is not present in the data, then this equation is going to help me out. Okay, so that's it. Now in the same way, you can see here the distance between the observed value and the estimated value is your EI. Okay, we are discussing the sample line, that's why it is EI. Now you talk about this dotted pink line. This pink line is actually explaining you the regression best fit line of the population data. Okay, so you just obtain the beta naught and beta 1 value with the help of your b naught and b1, and with the help of that you just maintain your population regression equation. And epsilon error value is also so evaluated with the help of our sample error value. Okay, that's it. So you can see here that this line is intersecting the y-axis at this point beta naught. So this is this value is the beta naught, and the slope of this line is this and representing the beta 1, and the error value you just calculate from here, that the observed value is over here and the estimated value is lying at this point. So the distance between these 2 points is your epsilon I. Okay, you substitute over here, you get the equation. So this equation is not the objective for ours. We are not forming this equation on the basis of the sample data. On the basis of the data, we are obtaining the sample equation. With the help of sample equation, we just obtain beta naught, beta 1, and epsilon I, and we then just format the same equation comprising the population data values. Okay. As far as this mu y x is concerned, this is actually explaining you the estimated population value, and it is equals to this that I have just discussed in the beginning. I hope this would help you.